So once again, I'm standing in the way between you and delicious dinner. So we'll make sure we'll wrap this up very beautifully, and so we can all finish and go to the dinner session. So in this session, we're going to introduce you to AgileAssets Portfolio Analyst. Portfolio Analyst in our product suites, portfolio analysis sits on the very top of all the product lines. It takes input from the analysis product like pavement analysis and bridge analysis, and optimize the funding allocations between different asset types. So as Erlen has introduced, my name is Ting, and I've been working with AgileAssets since 2014 and been working on the implementation of analysis product ever since. So before we dive into the application, I'd like to talk about the origin of the problem. Like any other products in our product suites, a portfolio analysis originates from the real problem in the transportation agency. In this case, is the funding allocations. If you've been using the paper analysis or bridge analysis, you will know that a lot of the problem is actually about the resource allocations between either time or between different locations. So in portfolio analysis case, this is about the allocation between different asset types. This becomes especially important when an agency is trying to build an enterprise-level asset management system. And a lot of the case, we want to allocate funding between among bridges, pavement, and safety, stormwater, this kind of big culverts. So this type of issue becomes very important. We used to know that we used to think comparing different asset types is like comparing apples and oranges. This is indeed true because different asset types have different costing method, different quality and performance measurements, and more importantly, they can have completely different risk factors. So taking all this into account, then when we're trying to balance the funding allocations or resource allocations between different asset types, it becomes very difficult and challenging to visualize and evaluate the overall impact of this of different investments and different investment with an overall objective. So if this is very difficult, and we've been known for a long time that it is very difficult, then why do we still want to solve this problem? Because the first one is always money, money, money. By optimize the resource allocation between different asset types within the agency, you will be able to save a lot of money. And partially optimized solution is not the best solution. We all know that. This is especially true if we can apply the concept of economy of scale. So imagine if a major pavement project can be aligned with a major bridge projects. You can basically reduce half of your traffic user cost and the traffic congestions. So, and especially this will save a lot of user costs first. And second off, for agency itself, it will be able to save a lot of money by reducing the resources you need to move the transportation, to move the construction resources and the construction crews. The second one is by optimizing the allocations between different asset types or different functional areas, the agency can have a much stronger can produce a much stronger and number-driven results for your funding allocations. This will makes the number. This does not only make the number look more justifiable. It also gives the citizens and the legislatures a lot of times more confidence. And as a result, the citizens will enjoy a network with a much higher quality. So we all know that there is benefit to do asset allocations, but how do we how are we able to solve this problem? We all know that a lot of time pavement bridges have completely different objectives. And in this case, we are trying to compare apples and the oranges. So the first approach is what we call a neutral approach. So this neutral approach is actually very intuitive. So what will happen is that we will try to find what we call a Pareto efficient frontier or Pareto efficient solution. A Pareto efficient solution is when part of this solution cannot be made any better without another parts of the solution become even worse. The most simple situation is when you have one constraint and one with one objective. For example, you have a budget constraint, you want to maximize your pavement condition. So when you if you have been using the pavement analysis and use the optimization to run the analysis, you will naturally get you to the efficient frontier, and any other solution that's from analysis will actually be actually worse than the efficient frontier, because you can either get better results using the same funding resource, or you can achieve the same network condition with a smaller funding. So if we are bringing this concept, the concept efficient frontier, to multiple objective analysis, we are essentially getting not a line of Pareto frontier, but a surface of efficient frontier. This surface basically represents a huge investment portfolios that with a mix of returns and the risks. If we are mathematician, then we can say our job is done here. Our job is done. Why? Because any points on the efficient frontier represents meaning they are equally efficient to each other, because you cannot get any better than this points under the same budgets or other resource constraints. However, it does not drive the decision making, for example, because it does not take decision makers' preference into the consideration. When we say decision maker, is usually the agency's stance or agency's overall attitude or strategy into the investments. So that means at the end of the day, even if we stop here, we still couldn't have. We are still not getting a very implementable decisions. So there are several ways to be able to get the decision to be implementable. So there are several ways to take the agency's preference into the consideration. The first one is what we is a posteriori method. In this method, we basically calculate all the possible efficient frontiers beforehand, and after we have all the results, we apply the agency's preference into that all the efficient frontier and pick the best one out of it. Intuitively, this is a very straightforward method and should be it's very easy to do. But in reality, we found out that to calculate all the possible efficient frontier is very resource intensive. It's almost impossible to do that. The second way is a priori method. So in this method, we basically take the agency's preference we bake the agency's preference into the optimization process itself. So when we run the analysis, when we run the optimization, it will a solution that best satisfy the agency's preference is developed during this process. A very commonly used method is called a utility function. So in utility function, we basically create an overall objective that covers different asset types, like bridges, like pavements. So when we apply the overall objectives, we'll be able to encompass all the asset types. The next one is another type of way to approach the solution is what we call interactive method. So in interactive method, the solution is achieved by having the decision makers approach the decision iteratively. So in each iteration, the decision makers will be presented with a near optimal solution, and the decision maker will describe how they would want the solution to be improved. For example, how they want the fundings to be more allocated to in line with agency's strategy, and then this input is taken into account in the next round of analysis, and then we produce another round of results, and then decision makers evaluate the result again, and then provides more input. And this process is iterated until the analysis engine produce very satisfying results. So. Technically, this way we'll be able to produce a much suitable result. But the thing is, this method takes a much longer time as well, much resource. So in portfolio analysis, we use the utility function approach, because it's very easy to understand. It's very easy to explain to a wider audience, and therefore much easier to implement in a big agency. Okay, so next I'm gonna briefly talk about how AgileAssets portfolio analysis works, where the apples and oranges lives happily ever after. So portfolio analysis is an integrated solution, meaning that it takes the results from bridge analysis and pavement analysis and safety analysis, and evaluate the combination the results from all combinations of analysis. If you have used the pavement analysis or bridge analysis, I'm sure you've been very familiar with how the workflow works. So we basically get the performance model running, and then we predict the section's performance, and then we use the decision tree to recommend treatments. Then we run the optimization engine to get the best conditions out of the constrained resource, and then will produce the work plan. And a similar approach is followed in the bridge analysis as well. At the end, both modules produce the optimized work plan and send the work plan to portfolio analysis. In this stage, portfolio analysis will use the utility function to evaluate and visualize the overall impact, overall effects of the work plan, and therefore you were able to have a better view of the cross-asset funding allocation and their results. So another part that we included in the portfolio analysis is the post-processing module. Components. In post-processing components, what we do is apply the economy of concept, and we will be able to move projects around across different time and locations. So we will be we'll be able to group the project into a much bigger projects, and therefore be able to save money by reduce the traffic congestions and reduce the amount of resource that a construction resource that DOT agency has to move around. So that you will be able to produce an updated work plan and updated cross-program work plan that best suits the agency's needs. Okay, so to summarize our products, the first one is we have in the updated portfolio analysis, we have improved the statistics and the graphic reports. Now you will be able to basically, you will have a huge amount of possibility of how you want to see the reports, and you can just select different reports by right-click the reports and do the selection. Then we have a new big picture window, which allows you to fully evaluate the results of the utility function. Then we have the new post-processing process, which allows you to achieve a better economy of scale and move the projects around to improve the performance from the resource consumption. And then also we have included the new work plan management. In this case, each regions will be each regions or district. If a DOT is using a very decentralized work plan management approach, each regions or district will be able to prepare their own work plans, and then the state or main office will be able to collect each district or region's work plan and creates a statewide work plan and then evaluates the results. So next, I'm gonna switch the gear and transfer the presentation to Shafiul, which will give a case study of how how we can use portfolio analysis to do some trade-off analysis.
Thank you, Ting. So for this specific case study, I will. Ting is a PMS guy, and I am actually a safety guy. But for some reason, we don't have a safety project in the analysis, so I will pretend to be a bridge folk and try to get some money from the trade-off so that I can maximize my bridge condition. So in this case study, we have like $4,200 million investment money, and what we have to choose between a bridge and the pavement projects. And the agency has some constraint. The constraint is we cannot have a poor condition for the bridge or the pavement. So less than 15% of the condition should be, that is the threshold. We cannot go beyond that. So let's take a look. So before I'm going to that case study, as Ting already mentioned, that there is always an improvement opportunity for us. And we talk about the efficient frontier. If you look at that diagram, that the trade-off analysis, sometimes it actually helps you to lower the cost and bring the added values for that. So any combination of the points that you see here in this diagram, you can actually pick up a point and see that there is always an opportunity to improvement. So even spending less money, you can get a better performance. So that we call it the improvement opportunity for you. So we have to make the best decision from the big picture and making sure we are maximizing our conditions of the roadway. And we have to actually look at the composition of the projects. And I mean, if we just go for maximizing the condition and then don't look at the composition of the project, we might come up with a very erroneous decision. So we need to make sure that we're taking care of both these aspects. So we have infinite possibility, right? We have this efficient frontier, and the way the big picture shows, these are the combination of the possible portfolio. So you have to come up, what is your budget, and pick up a point, and then see what are the combination of the projects and how far you can make improvement to that. So let's start from the big picture. So this is my big picture window. We have all this combination of the different projects and using the utility function, we are predicting the network performance. And as I mentioned, our budget is $42 million, right? So if we pick up a point at $42 million, and see there are some opportunities for us. There are at least four data points on that specific regions. So let's pick up a point. Let's say the point is A, right? And let's take a look what is there. Point A, we have, let's go back one more step just to show you right here. Okay, so point A is right $42 million, that is our budget, and overall network performance is 0.45, right? But I see there is a point on efficient frontier, point B, which is lower in cost, $39.50 million, right? And overall performance is 0.6. So that seems to be really appealing to me. Okay, I'm thinking, okay, I might go to point B instead of point A because that is giving me a better network performance. Now the next question will be, let's look at the treatment strategies for both options. What are the treatment strategy in point A versus point B? So the option A, budget is $42 million. So if you look at that, so now in the first one, I'm getting more money and Ting is getting less, right? So we are, my performance is 0.46 versus Ting, he's getting 0.4. So looks like bridge is performing better, right? In the next one, which is the lower one, point B, the opposite. So bridge is only getting performance net health index up to 0.3, where the pavement is getting almost close to 1. So what I need to see, need to drill down a little bit and see what is going on with this investment strategy. So if you look at the first one, there are a lot of red, right? On the top, the middle picture, top one, there are a lot of red zone, and the red is actually the investment for the renewal of the bridge, right? So we are making a lot of renewal of the bridge, making a lot of more bridges, looks like that's why we're spending more money. We don't have a lot of money for preservation or for corrections, right? So that's why my bridge condition is improving, but the pavement condition is not that, it's not improving much. For the investment option B, $3,950 million, we're spending actually some portion of money for renewal of the pavement or bridge. We're not sure, but we need to drill down and see. And then we are spending some money for correction and preservation. So we might need to go one more step and see what is the actual composition of the project. So what I did, okay, I just pick up 1 year. Let's say in the middle of my investment year, what is happening? And now this is really, it will lead me to better decisions. So we can see that in 2018, I'm actually spending a lot of money for bridge, making a lot of renewal of the bridge, rehabilitation of the bridge, pavement, spending some. But if you look at option B, I'm not spending any money for bridge. I'm just letting the bridge as it is. So this is a scary scenario for some agency, right? You're not spending for bridge. If your bridges are all new and you don't need to do anything for next 5 years, then it makes sense, right? But if his bridges are not in good condition, you will be in bad shape if you do that kind of investment strategy. So we might need to do one more picture. Okay, what will be the impact on the performance? I look at my investment strategy. The next thing I need to see the performance of my pavement and bridge. So again, we start from this big picture, and the first thing we look is the bridge performance for investment A and investment B. So as you know that for investment B, we hardly spend any money for bridge, and what you see that the condition of bridge is deteriorating, right? In the bottom, in the middle graph, if you see that the red is increasing, so we started with like maybe 10% of the bridges that was in the worst condition. Now down the line in 2020, that will be up to 17%. So we are really deteriorating the condition of the bridge because we are not spending any money for the bridge. The top one, when we are spending more money for bridge, our condition is pretty much okay. I mean, for bridge, if you look at the red lines on the top pane, the top graph, my condition is not deteriorating. It's like stable condition of the bridge. And if you look at one more thing, the green, the graph that shows you the conditions for the good roads, right? So if you look at that for bridges, since we're investing a lot, in the first year, there was roughly like 30% of the bridges in better condition. Since we make a lot of new bridges, a lot of renewal of the bridges, that improves a lot. And after end of 5 years, in 2020, I got almost like 60% of the bridges that are in good condition because I built a lot of new bridges or just rehabilitated my bridges. So getting better there. In the second option, I did not do much for bridge. So the condition of my, each of the condition of the bridges that my condition of the bridge really deteriorated. So my good condition of the bridge is started with like say 20%, at the end of 5 years is roughly 10%. So I'm really not doing anything for the bridge. Now let's take a look at the pavement. Really the opposite picture, right? We're investing a lot in option 1, not making good investment for pavement, but making some investment, right? So the condition is not that worse like bridge, but say we start with 10% poor condition for pavement. After end of 5 years, it's roughly 17%, right? But if you look at our first case study, we have something called we have a policy decision, right? We cannot go 15% or less for any poor condition of that. So considering that condition, we cannot actually pick up option A because the bridge condition really it's hitting like almost 17% poor condition at the end of fifth year. So although that option is good, option B, but we cannot actually take option B. We have to stick to option A, or we need to come up with some other investment strategy. So actually, portfolio analysis give you that possibility. What you can do, you can add additional projects to one of the option, and then modify that and re-estimate your portfolio. So you might come up with a middle ground, like, okay, when you're not putting a lot of money for bridge, a lot of money for pavement, you're just coming up with a solution that will work for both sectors. So the quick summary of the case study, that there are multiple ways that we can make decisions. There are a lot of possibility, and if you just move around the efficient frontier, that actually gives you a better way to find out those possibilities. This is the first one option for us. Then you have to actually investigate that in the big picture window, and we started with the big picture window, and we saw that we find out a couple of points and then compare the composition of the projects. We found that lower cost in alternative B than A, so it's providing more return on investment. Then we analyze our treatment strategy. Definitely we found that we have better economy of scale for B. Remember, B was roughly like $3,900 million, so it was really, it's a better economy of scale. So lower cost than renewal for option A. And we actually got this picture when you analyze the options, right? How much you're spending for renewal, how much per corrective option, how much for the preservation. And we found that we're spending a lot more dollar in option A because we're doing a lot of renewal of the bridge. Then we found an interesting picture that bridge was completely overlooked, right? So we did not spend any money on the bridge. So I will not be happy. Ting will be happy because I'm the bridge guy, so I really want to make sure I got some money. So that was completely overlooked. Okay, if we have bridge conditions are not compromised. So if my 15% threshold, that is not compromised, I might have taken that decision. Okay, let's have the bridge go as it is, it's all perfect condition. After 5 years, it not deteriorate that much. But that was not the scenario, right? So I have to come back and ask for some money for bridges. Revising treatment strategy would help. So I would say cherry pick sensitive bridges if necessary. Ting talk about apple and orange. I will bring one more fruit here, cherry. So do the cherry picking so we can make sure that we consider some sensitive bridge and bring those into the picture and come up with an alternative C option maybe in between A and B. And that will probably be the best solution for this strategy. And finally, condition forecasting. That was something really important. So we need to, because our policy was we cannot degrade more than 15%. So we have to see the actual condition forecasting and see what will happen. And we found that in option B, since we did not invest anything for bridge, we started with 10%. I mean, at the end of 5th year, it was 20%, right? It was really bad. For pavement, the condition improved in B because we put a lot of money. So it started with 14%, and at the end of 5 years, it was 3%. So definitely the answer is you have to deal with alternative scenario. We have to come up with project strategy, look at the forecasting of both of the options, and try to come up with the best project. And your project will be definitely impacted by the policy and by the decision. And I will refer to one document. We have NCHRP report 666 that was published in 2010. So it had some performance-based resource allocation. And what it meant that your investment decision is not only coming from your optimization. It's a combination of the results from the optimization plus your customer feedback, your expert opinion. So that's how you actually make your best decision. And trade-off is something that you definitely need to think about that aspect, that how you can, because it's a cross-functional area, there are a lot of decision makers are there, so really need to respect everyone's opinion and try to come up with the best strategy. So with that, I would like to conclude my part. Do you have any question for myself or Ting?
Also, we have a workshop, a hands-on workshop for portfolio analysis on Thursday morning. So if anyone is interested, welcome to the session. I forgot the room number though.
2 questions. Ting.
How is risk handled in that? Is that part of one of the utility functions, or is it handled in some other manner in calculating risk and into the decision?
Right now, risk is not explicitly handled in that. I think Bridges is trying to take a risk into consideration now, but you can, for sure, if you can create a utility function that take risk into account, then that can be included in the portfolio analysis.
Well, I just wanted to point out that actually B is better than A because it's Pareto. It's just problem is that utility apparently was chosen such that it says breach to the entire organization is not important, so we can ignore it. It just shows how important it is to talk to each other and figure out, hey, let's value things equally. And unfortunately, in this example, it turns out that breach, it's organization more cares about payment.
Well, actually, Bridges already weighted more.
Just to explain why it decided, let's forget about Bridges.
Actually, in that example, Bridges already weighted more than pavement.
Yeah.
Any more questions?